Hello guys, today is a special day. It is a special day because we have just begun a new year. I would like to take this opportunity to wish you a happy and a prosperous new year. I know you have dreams. All you need to do is to eat well, drink well, exercise and work hard. And with all these things done, I know your dream is not just a reality, but a possibility. Now, Stata has a broad range of exceptional regression techniques. In today's video, I'm going to show you how you can use the regress and its related commands to estimate linear regression via the OLS, or the ordinary least square algorithm. Without spending my time, let us go to the class and check it out. Thank you. Okay, so today I start by first of all taking you to the folder where I have my data set for today's tutorial. And so inside the folder, I have a data set called life expectancy. So I get straight into that. Okay, so this is the data set. I'm going to first of all start by describing the variables in this data set just to have a fair idea of how each variable was measured. And so I do that by typing the command describe. Okay, and then I press the enter key. So this is the information I have. These are the variable names, and this is how each variable is actually stored. So this one, for instance, tells me that this is a string variable. Okay, and then over here, the last column, I have a brief description of each variable, just to give me a fair idea of what each variable stands for. Okay, at the top here also I have a general information about the data set itself, but that is not the focus, or that's not my focus for today. Okay, the second step is to compute a basic statistics, okay, for the variables that I'm going to use for today's analysis. Okay, just to have a fair idea of the distribution of each of these variables within the data set. So I do that by typing the command sum, in other words summarize. You can type the full name, or you can type the full name summarize, and then I select life expectancy, GNP, and safe water. These are the variables I'm going to use for today's analysis. Okay, specifically this is going to be my Y, what we know in econometrics as the dependent variable or the predicted variable. And these two, the GNP, PC, and safe water, are going to be my X variables. In other words, the explanatory variables, or the predictor variables, or the independent variables. Okay, so in computing the basic statistics, I press the enter key, and over here I have this information. So this tells me that averagely life expectancy is 72 years, and then GNPPC is about this value, and safe water averagely is about 76. Okay, this tells me the standard deviation in the data set. So in terms of how this variable deviates from the central point, I have 4.7, and the rest follows as that. Another key information I have here is the distribution in terms of the minimum and the maximum value for each of the variables of interest. And so in terms of life expectancy, I have the minimum life expectancy to be 54, and the maximum is 79. Likewise, I have for GNP and safe water as well. Okay, like I said, today I'm using life expectancy as the dependent variable, or the predicted variable, which is the Y, and the GNP and safe water will be the X variables, or the predictor, or the predictors, or you can call them explanatory, or the independent variables. Okay, so I move in now to estimate the linear regression. Okay, and so in Stata, the command for linear regression is just the word regress, or you can type reg, that is reg, which is the first three letters. And then in estimating linear regression, in Stata or any other software, the y variable comes first. So I pick the y variable, which is the life expectancy, followed by the x variables, which are the explanatory variables. So then I press my enter key. Okay, so this is the result or the output for our regression that we intended to estimate today. At the top left corner here is the f test in terms of the sum of squares. So the f test is actually tested on the null hypothesis that the coefficient of all these x variables is equal to 0. Okay, so now that we have the f statistics to be significant, which means we reject the null hypothesis and accept the alternative that at least one of them is significantly greater than 0. So that is the f test. Okay, now at the top here are the basic diagnostics as far as our regression or our result is concerned. In the data set, it is telling us that we have number of observations, that is number of observations used for the estimation of the regression is 37, and then the f statistics or the f test that I spoke to you about has a degree of freedom of 2 and 34, and it's actually about 38.94. okay, the p-value tells us that the f statistics is highly significant, and therefore we reject the null that the coefficient of all these variables is equal to 0, and accept the alternative that at least the coefficient of one of these variables is greater than 0. Okay, now this is the r squared. So the r squared also tells us the percentage of variations in life expectancy that's been explained by the explanatory variables or the independent variables. And so here what we have here tells us that about 70% of the variations in life expectancy is being explained by GNP and safe water. So that is what we have here. But the key difference between the r squared and the adjusted r squared is that the adjusted r squared takes into account degree of freedom, and so this one more or less penalizes the researcher or the data analyst for adding more variables. What it implies is that, or what it means is that, as you add more and more variables, your adjusted r square goes down and your r square comes up. So that is the difference. So that is what I mean by this adjusted r square penalizing the data analyst or the researcher for adding more variables. The more you add more variables, or the more you add on variables, the more this value or the adjusted r square goes down and your r square comes up. The reason being that the adjusted r squared takes into account degree of freedom, and this does not take into account degree of freedom. Okay, so let's move to the down here, which is the main result that we have. At the extreme left column is the names of the variables. Okay, and then the next is the coefficient, where we have these estimated parameters, what we popularly refer to as the betas. So this is the intercept or the constant term. Okay, so what this one, for instance, implies is that as it is expected, life expectancy tends to be very high in countries with high GNP, and then again life expectancy tends to be very high in countries with high amount of safe water. That is what this one means. Over here we talk of the standard errors, which measures the statistical accuracy for every estimate. So here, the lower it is, the better for the result that we have. And so it is used to compute the T statistics, which is the test statistics for each of these variables, for the individual variables. Okay, so here we have the standard error for the GNP to be this value, and that of safe water to be this, with the constant term being 2 point something. Okay, the T statistics here actually is the test statistic for each of these variables. It is testing the null hypothesis that, for example, the coefficient of GNP is 0. Now that we have the p-value to be significant, at least at 10%, we reject that null hypothesis that the coefficient of GNP is 0 and accept the alternative that it is significantly greater than 0. Okay, or specifically, if I come to safe water, the null hypothesis that the coefficient of safe water is 0 is rejected, okay, in favor of the alternative that safe water is significantly greater. The coefficient of safe water is significantly greater than 0. So that is what the T statistic stands for. Okay, now over here, which is the p-value, this and that is an indicator, or is what we use to tell whether a variable is significant or not. Actually, you can use any of these to tell, but you need to be very experienced in reading results of this nature in statistical analysis or in econometric analysis. Otherwise, this is easier to read. If it is less than 0.01, in other words, if it is less than 1%, then it means that the variable is highly significant at 1%. If it is less than 0.05, in other words 5%, then we see the variable is significant at 5%. If it is less than 0.10, in other words 10%, then we see it is significant at 10%. So looking at the p-values for each of the variables we have, including the constant term, you could see that, or you can see that this is significant at 10% because it is less than 0.10, in other words 10%. Over here, it is less than 0.01, in other words 1%, so we see it is highly significant. Likewise, this as well. So the confidence interval is also used for the same purpose, just to tell which variable is significant or not. Actually, the default is the 95, so you can also choose an option, another confidence level like 99 in your estimation by adding that particular option, and you are going to get the results at 99% level. Okay, I'm gonna try and then estimate the margins for safe water. Okay, actually, if you take the whole model, the marginal effect is the same as what we see here, but I'm going to ask the software to compute the marginal effect at mean level for some number or quantity of safe water, and then we see how the result will appear. So for instance, I type the command margins at, then I open a bracket, safe water, okay, equal to, then I open parent to 12, okay, then I close the parent. Okay, then perhaps I want a graph to come with it, so I type plot and I press my enter key. So this is the graph, but let's look at, so what it means is that it's a linear predictions at this, so margins at means, so linear predictions at this. So we requested before 2 and 12, and so we are saying that at safe water equal to 12, what is the mean margin? It is 57 years for life expectancy. It means that if a country is having a level of safe water at 2, this will be the life expectancy for that particular country on the average. And likewise, if a country is having a level of safe water at 12, then this will be the average life expectancy. So that is what this implies. Okay, let's pick the graph. So with the graph, it tells me that as quantity or unit of seawater increases for a country, the life expectancy, the average life expectancy also increases marginally. On the average, it increases marginally. So that is what the graph is also telling us. Let's increase the levels of the seawater. So in this case, I say give it to me from 2 to 12 with the interval of 1, the same command, and I press my enter key. So this is what I have. I'm going to press them all. So here at 1, at 2, there will be a value up till 12. Okay, so just to push the graph aside a bit. Okay, so at 2, okay, so if you watch here at 2, I have a mean marginal life expectancy for a nation to be 57, and that order up till 12. So that is how the margins at means, or the margins are computed. And graphically, again, it is telling us that as the quantities of, or the level of safe water for a country increases, the margins for life expectancy on average also increases, or the average life expectancy for a country increases marginally. Okay, increases marginally. So that is what this actually implies. Okay, so you can also estimate the linear regression if you want to use the interactive means by pointing and clicking without typing commands. Then you come here, statistics, and then you choose linear models and related. You see linear regression here, so you pick it up by clicking on it. Then when you click dependent variables, we use life expectancy. And when you come here, the independent variables, I mean the explanatory or the X variables, we choose GNP, PC, and safe water. Okay, so you just press either submit or OK. The difference between OK and submit is that if I click OK, this window will disappear. However, if I click submit, this window still remains, so that if I want to continue or modify the model, I can have the opportunity to modify it. But I'm going to choose OK. So this is what I have. You can see that the result is exactly the same as we used the command to estimate, to estimate the model. Okay, the same way, if you also want to compute the margins at means, you can do the same thing by again coming to statistics, and then you come to post estimation. Okay, so at the post estimation, you choose marginal analysis. We have marginal analysis, test, and all that. So we just click on the arrow for the marginal analysis, and then we choose marginal means. Okay, so then I launch it. I can close this one now. Then I choose a covariate I want to compute the marginal means on. So I choose safe water, just as I did. I don't have any interactive term, so here values to compute estimate at. So remember, we selected 2, okay, with an interval of 1 to 12. Okay, so again I click, let me add my plot. So I say draw profile plot of results. So I click OK, and then again the same results is obtained. Okay, the system or the software gives me the same result. So there are two ways you can use. Either you estimate linear regression by using a command, okay, by issuing the command that I just took you through, or you can interactively communicate to the software to perform the activity the same way. Later on in my subsequent videos, I'll come and show you the benefits of using the command over that of the point and click, or the means of interacting with the software. Okay, thanks for stepping by. Make sure you subscribe to my YouTube channel so that you will not miss subsequent videos that will come. Thank you.